And so now let's go to our last presentation by Trent Ford from the University of Illinois, Urbana-Champaign, who will provide a survey of everything else, so to speak, some part of everything else, some of the non-CPC tools being developed for flash drought. So Trent, go ahead.
Yeah, thanks, Marina. Go ahead and go to the next slide, please. All right, so title slide here, some emerging tools. We heard from Brad and Gwen about some at CPC that are either experimental or operational, and now we're going to go through some other ones that are broadly similar but also have some important differences. Next slide, please. Okay, so I thought this was important to start with here is sort of giving an overview of how flash drought manifests often, which sort of is necessary before thinking about what we need to monitor or possibly look at to provide some early warning or maybe even prediction to flash drought. So I'm stealing this figure here from Jason Atkins' paper and a few years ago, and you can see on the left-hand side is kind of the early signals of flash drought. We have below normal precipitation, which is absolutely necessary for any drought, let alone flash drought. But you know, the calling card of especially agricultural and ecological flash drought, where we see ag impacts and impacts to ecology, is above average demand. So that atmospheric demand, often that comes with temperatures that are above average, strong winds, low humidity, that sort of thing that's coupled with that below normal precipitation. And what that does is it quickly depletes soil moisture, especially in that rooting zone. And we can see that towards the bottom as we move out in time from those atmospheric drivers, we see a decrease in soil moisture, and kind of the namesake of flash drought means that happens rather quickly, and to the point where we begin to see deteriorating vegetation, ecological health, and that can ultimately manifest in agricultural drought or ecological drought. So when we're thinking about the timescales of monitoring and early warning, for monitoring flash drought, we're looking at things like, along with precipitation and evaporative demand, vegetation indices, maybe soil moisture. For early warning, before we see that agriculture or ecological drought set in, we really want to look a little bit earlier when we're looking at those atmospheric conditions as well as maybe soil moisture. So that gives us an idea again of what sort of indicators we really should be looking at when trying to forewarn or monitor flash droughts. Go ahead and go to the next slide, please. Okay, so some notes up front before I start going through all of these products. First of all, this overview is absolutely not exhaustive. If I missed your favorite flash drought tool, please bring that up in question and answer, and please send me a link to it in my email, because they're, you know, one of the good things about flash drought really becoming notorious in the science is that there's a lot of tools popping up for monitoring and early warning. So if I missed one, please let me know about it. Second, this is not an endorsement, an advocation, or a condemnation of any individual product or technique. We're taking these products in groups, and what I'm going to do is summarize the advantages and disadvantages of using products based off of each of these individual variables. And so again, we're not endorsing any specific product here. We're trying to provide a good summary of what we're looking at, when maybe to use certain products over others and when not to. Go ahead and go to the next slide, please. Okay, so we're going to start with evaporation and evaporative demand focused products. And so evaporation, we heard about this, Gwen talked about this a little bit in some of the products from CPC. So we have evaporation and then evaporative demand, sort of the potential evaporation, which is driven more by temperature, wind speed, humidity, so on and so forth. I have these different summaries broken up into advantages and disadvantages. Again, these are very broad. They can vary a little bit between products that use evaporation or evaporative demand, but these are sort of broad advantages and disadvantages. So some of the advantages of evaporation and evaporative demand focused products, those that use that information to produce and either monitor or early warning. You know, evaporative demand has been shown, study after study after study has been shown that evaporative demand, elevated evaporative demand is very important for flash drought. We need those above average temperatures. We need a lot of drying out of that soil moisture. And in a lot of cases, just below average precipitation won't create that sort of rapid onset or rapidly intensifying conditions that characterize flash drought. So it's really important to get that high evaporative demand, and therefore evaporation, evaporative demand focused products can give us information that others may not be able to, for example, just precipitation alone. Also, a lot of these products, because of they're either drawn from atmospheric reanalysis data sets, other data sets, remote sensing data sets that have been around for a while, they often benefit from a relatively long climatology. So a lot of times I think both Brad and Gwen mentioned the anomalies, maybe percentiles kind of translated to the US Drought Monitor. Both of those often rely on a relatively long climatology to be able to capture not just the mean state of evaporative demand, but also the extremes. And when we're talking about flash drought, it's really the extremes that matter. So adequately capturing those really depends on a relatively long climatology, and a lot of these products benefit from that. Also, global scale, especially those that rely on models or remote sensing data sets, that they inherently have a global scale, which means that they don't just benefit the U.S. or one particular region in the U.S., but the entire globe, and that can be really important as well, as I'll talk about in a little bit. And then they have the potential for high spatial resolution. A lot of these products are at fairly fine scales, in some cases getting close to field scale spatial resolution, which for some other products, for soil moisture namely, we may not be able to get to. Some of the disadvantages is that models are really important for this data set, but of course, when we depend on models, all models are wrong, some are useful, and so the dependency on model information can create issues in certain situations. Evaporative demand, as I mentioned, is really important for flash drought, but it is not explicitly tied to precipitation, and it has a variable connection to soil moisture. Depending on the climate that you're in, if you see changes in evaporative demand or evaporation, they could inherently be tied to soil moisture. And in some climates, especially very humid climates, that may not necessarily be the case. And so evaporative demand and evaporation-based indicators may be better predictive of or better for early monitoring of flash drought in certain climates than others. And so that nuance has to be taken into account. And then, as Gwen mentioned, I think in the HITKey skill score plots that she showed before, the variable cool season performance, because evaporative demand is not as important in the cool season as the warm season, especially in more temperate climates. We can have different variable cool season performance as far as monitoring for flash drought in the cool season. Go to the next slide, please. So some examples of evaporation and evaporative demand focused products: the evaporative demand drought index, which is one taking the figure here on the right hand side, one of the more recent EDI maps here, and the evaporative stress index is another one, and then the standardized evaporative stress ratio. Now these are all similar to each other. Some use for example, EDI is focused on evaporative demand, whereas the CSER, standardized evaporative stress ratio, takes the ratio of evaporation to evaporative demand. So how much evaporation, how close evaporation is to meeting the potential of evapotranspiration, which can give us a bit of a signal about soil moisture and moisture conditions. And so an evaporative stress index also takes into account vegetation conditions as well. So they are varying to a varying degree, but they're all sort of getting at the same idea: as how arid is the atmosphere, and how much does that relate to how much can that drive the amount of soil moisture depletion leading up to flash drought. Okay, go ahead and go to the next slide, please. All right, so then on the other side, when we think about flash drought as an atmospheric kind of driven event, we think of the other side of evaporative demand as precipitation. The advantages of precipitation focused products is that precipitation is a necessary component of drought. It's the same with flash drought. Precipitation products also tend to benefit from a long climatology. We've been measuring precipitation in many places around the US and globally for a long time now. National to global scale, often the spatial extent of precipitation is not usually an issue. There is potential for high spatial resolution, especially with some incorporating radar and remote sensing information. And this is important from my perspective, coming from a flash drought from the soil moisture perspective. We don't really have a lot of good forms of information for calibration and validation. It's certainly not everywhere across the US, let alone globally. For precipitation, that's not the case. There's multiple forms of information. There's assimilated model-based data sets, entirely remotely sensed or radar-based data sets, and then you have entirely gauge-based data sets, and then you have these hybrid data sets that are a mix of all three or more. So what that gives us is a lot of information to do calibration and validation, which is, again, coming from a perspective of a data set that may not have that benefit, can be really advantageous. And then we've been studying precipitation and its effect on drought for a long time now, a century or more. And so the legacy of that knowledge fits into how well we can anticipate impacts based on precipitation-based indicators. The disadvantage of precipitation is that, kind of on the flip side of the disadvantage of evaporative demand, it's precipitation is not tied to evaporative demand. So even if we have below normal precipitation, if it's cooler, if it's more humid, we may not have the evaporative demand. We may not get a flash drought in some regions. Precipitation is highly variable as far as the quality and quantity by country, which means it's not necessarily very consistent across political borders, which can create a problem when you think about global flash drought monitoring. And there's a timescale mismatch with precipitation. When we think about a 30-day total or a 60-day or a 6-month total, for example, even if you update that once a day, it's not necessarily going to be highly predictive of when a flash drought occurs. A 30 or 60 or 90-day precipitation deficit is necessary to get flash drought, but it's not necessarily going to be predictive of when that flash drought will occur. So that's going to be really important. Whereas often precipitation alone is not a great monitor of flash drought, but it can be combined in tandem with something else to make a good product. Go ahead and go to the next slide, please. I guess oh, there it is. Okay, good. All right, so precipitation focused products, and to this last point that I made, one of them that I'm picking out here, the integrated water portal. Right now it's being hosted by the North Carolina State Climate Office. I should mention though that it's soon moving to the Southern Regional Climate Center, and so that'll be exciting to see that there in its new home. One of their products they have is a daily updated SPEI, that's Standardized Precipitation Evapotranspiration Index. And so kind of to my last point from the previous slide where I was mentioning coupling precipitation with another indicator like evaporative demand, that's what gives us the SPEI, which can better monitor more rapid changes in evaporative demand on top of precipitation deficits that lead to flash drought. We also have really important ACIS SPI maps, or Standardized Precipitation Index maps, from the High Plains Regional Climate Center, among others. And then the global SPEI drought monitor, which is also a really important indicator, again, using that Standardized Precipitation Evapotranspiration Index, but at a global scale for global flash drought monitoring. Okay, go ahead and go to the next slide, please. All right, I guess the second to last group of products are soil moisture focused products. The advantages of soil moisture is that it's arguably where the rubber meets the road. Soil moisture is indicative of agricultural and ecological impacts in many areas. We begin to see those agricultural and ecological impacts when soil moisture reaches the point, whether it be the wilting point or some other point at which plants are no longer able to meet that water demand. And soil moisture integrates the effects of precipitation and evaporative demand. So it kind of combines the two together. Soil moisture products, there's the potential for national to global extent for scale, and it tends to have a low false positive rate. We tend to not get a lot of false positive drought warnings when our soil moisture is low. When we have very dry soils, we tend to see those drought impacts pretty consistently, which is important. The disadvantages of soil moisture is that we have a really highly variable and lacking in most places in situ monitoring infrastructure for soil moisture. What that means is we're relying a lot on models of remote sensing, and I'll see this sometimes in the literature where we're validating a soil moisture model with another soil moisture model, and it's just because we don't have that in situ monitoring infrastructure in many places that's dense enough to really do a lot of work with that information. There's a variable climatology of soil moisture. In some places we have 20 to 30 years of information, but in most places, especially with station-based soil moisture, it's often very short. That goes the same with a lot of our remote sensing products too, where like SMAP, for example, which has been up in the sky for 6 years now. It's good. That data set is important, but the relatively short climatology makes it a bit challenging to convert to, again, we're talking anomalies or percentiles. The spatial variability and representativeness is always a problem with soil moisture, and using one point to represent a whole field, let alone a whole county, let alone half a state, is really complex. And then there's communication complexities. Even with current soil moisture monitoring data sets and tools that are available, I see a lot that there'll be a product put out and it's a percentile, or it's a volumetric water content, or it's an anomaly. And for folks who aren't working day to day with soil moisture, it can be really difficult to translate that to, okay, how much water do I either need to apply to my crop, or how much water is my soil lacking in the root zone? And so communication with soil moisture is a bit trickier than it is with something like precipitation. Go to the next slide, please. Some up and coming, so soil moisture based flash drought monitoring has been lacking other types of data like evaporative demand and precipitation, and for good reasons. All the complexities that I just talked about with soil moisture, but there are some up and coming products. I think Brad and Gwen hit on some with CPC. I also wanted to highlight the Flash product, Flash Drought Assessment using SMAP hydrology, which is based the Vadosone group there at Texas A&M. I showed an image here of recent, and this is using SMAP information at a global extent to try to indicate where there may be areas that are going into flash drought or coming out of flash drought, and it's a really novel tool that I think has good front end development. So that's one to check out as well. And then there's some work by a few groups, and I know CPC hit on this a little bit, but there's some work in a few groups that are trying to couple soil moisture conditions, either current or near term predicted soil moisture, with subseasonal seasonal forecasts of meteorology. So trying to get at, okay, here's where our soil conditions are at now, and then here's where our atmospheric conditions look to go in the next couple of weeks, 2 to 4 weeks, maybe farther out. And that gives us a bit of an early warning for areas that may be going into flash drought. Not areas that are in drought, as Gwen kind of highlighted. Those areas are not really what we want to look at for flash drought. It's the areas that have the potential in the next few weeks to go into flash drought. So that's something to look at as well. And there's a great paper by David Lorenz and the Wisconsin group there that was just published a few days ago. Go ahead and go to the next slide, please. Okay, last bit here, integrated products, and I wanted to touch on these. These are taking a bunch of different information. It's not just soil moisture, just precipitation, or just vegetation indices, but a lot of things put together. Some advantages, of course, you can, when you take in a bunch of different data points, you can leverage the advantages of those individual variables. So it kind of maybe removes some of the disadvantages of the individual products. You have the potential to depict nonlinear relationships, which we know exist between precipitation, evaporative demand, soil moisture, and it can maybe provide a confluence of evidence that can perhaps result in a more stable result. The disadvantages of integrated products is that it may not respond as quickly as other drought products. We see that with the U.S. Drought Monitor. It's updated weekly and takes into account many longer term indicators that may not be as relevant for flash drought. And the communication interpretation is complex as well. We're not just saying, okay, here's how much precipitation, here's how much rain you're going to get next week. It's here's how this was depicted based off a machine learning algorithm or something like that. It may just make communication and interpretation a bit trickier with these. Go ahead and go to the next slide, please. Some integrated products example, of course, we have the U.S. Drought Monitor, which is that confluence of evidence sort of approach at trying to get at drought monitoring. QuickDry does this. QuickDry uses a number of different information, but to its credit, it does update rather quickly, hence the name. And so it is actually a useful tool for flash drought monitoring. And then Beth Hall at now at the MRCC and at the Indiana State Climate Office has built a flash drought risk tool using machine learning, and they're working on that right now, and it's combining a bunch of variables together, and it has a lot of promise. So I wanted to highlight that as well. Okay, go to the next slide. Final thoughts. Thank God I'm done. A couple things. There is no single best flash drought indicator or product. I don't think there ever will be. Much like drought, it depends on the situation. It depends on where you are. It depends on who you're talking to. Are you talking to agriculture folks? Are you talking to natural resource managers? Are you talking to municipal water managers, for example? There's different, often complementary information from products, and so using them again in tandem really produces the best results. And then there are some aspects that do seem to be consistent among successful products. For example, focus on the onset intensification and the rate of change more than traditional drought indicators. So a lot of times when we think about traditional drought indicators, it's how much rain have we had over the last 3 months, right? That doesn't really give us an idea about flash drought, which is really about the potential of intensification. How bad is it going to get in the next couple of weeks? And so looking at the rate of change can be really important. Gwen hit on the rapid change index, which is really, I just wanted to highlight that again. That's shown a lot of promise to be applied to multiple different types of indicators to really reflect that rapid change. And then again, the inclusion of some sort of evaporative demand, because flash drought is so important the evaporative demand part is so important, it's really important to include. Last, current needs, as far as I've seen them here, as we think about the next 5 years of flash drought monitoring and tool production, and this list here is in order in my opinion of priority. I think the first thing is a stakeholder empowered flash drought product. So if we create 30 new flash drought products in the next year, but none of those are actually linked to what stakeholders actually need as far as information, that may not be as helpful as if we create 3 or 4 really good products that have stakeholder input from the beginning to the end. And then in lieu of time issues, I'll skip the list of the other current needs, but yeah, hopefully this was helpful, and I want to thank again the organizers here for letting me spill my thoughts here.
Well, thank you very much, Trent. Sorry